So in problem 3, they're asking us to solve this inequality, and the first thing I know whenever I see an inequality is I need to get this entire absolute value right here in red by itself before I can do anything else. So to get that absolute value by itself, the first thing I'm going to do is subtract 4 from both sides. And when I do that, it's going to leave me with x plus 5 inside of an absolute value is less than 12 minus 4, which is 8. Now, whenever you have an absolute value inequality, this is always going to break into two different problems. The first problem is going to be exactly what you see without the absolute value. The other side of this is going to turn into what's inside the absolute value, but then the rest of the equation, both the direction of the inequality and the result of the inequality, are going to change their signs. So it's going to instead point in the opposite direction, and it's going to be -8. So now I have to solve each of these by themselves. But to make things even more complicated, the fact that this is an inequality means that there has to be a link between these two problems. Because this is a less than problem, this is going to mean that we're going to need to say and as the link between these two problems. So when we're done, we're going to have to use and as a way to think about our solution here. So when I look at this, I can say, okay, if I subtract 5 from both sides over here, that's going to leave me with x is less than 5 minus 8, which is 3. Over here in green, I can see that when I subtract 5, what I'm going to get is that x has to be bigger than -8 minus 5, which is -13. And both of these are linked with the word and. Now, in terms of algebra, this is one way to show the answer. The other way that we could possibly show this answer as an and is to say, okay, if I take this right here and say, okay, -13 and 3 with an x between them. Notice that in the green solution here, the arrow is pointing towards the -13 and away from the x. Well, that makes sense. Now, if I do it this way as well, I can see that it still matches the pink answer over here where the arrow is pointed towards the x and away from the 3. So this is another way to write the answer. So this right here is the algebra symbolic answer. If I asked, what does this look like as a picture? Well, as a number line, we could say, okay, here's -13 right here, here's 3, and we know that we wanted all of the numbers where x could not be 13 but was larger than 13, so that would mean that we would get all of these answers. Then we saw that there was another answer that said, and I'll change this to green here. Let me double check and make sure that my colors are matching up. Actually, this one right here should match the green answer. And then we said that there was another one that said x had to be less than 3. Well, if I take a look at where these match up, that tells me that the overall answer is going to be an open dot and an open dot, and we want everything between them because that's where the green and the pink match up. So this is the picture representation of the answer. And then if I had to write this in interval notation, as an interval, remember intervals just say you start at your one number, you go to the other number, put a comma between them, and because these are open dots, they are not included as part of the interval solution. So the 3 different ways that we could possibly write the answer is we could write the answer this way as an algebraic inequality, we could write it this way as a picture representation, or we could write it this way as an interval notation.